Okay, example number 3. Getting a bit more complicated again. We've got y equals x, bracket x plus 1 to the power of 4, bracket 2x minus 1 to the power of 5. Now, we're used to having two terms being multiplied, one being u and one being v. In this instance, it looks as though we've got 3 different terms forming a product. So what we're going to do is we're going to group the first two together as if they're one term. So I'm going to say let u be equal to x, bracket x plus 1 to the 4. And then over here, I'm going to say let v be equal to the 2x minus 1 to the power of 5. Okay, now I'm going to put a pin in this for the time being. Okay, and I'm going to come back to that. If I go to get u dashed and differentiate this, what we can see is we've got a product again. So essentially we're going to have to apply the product rule twice. Let me just write that down for you. I'll just shorten it, product rule twice. Okay, just a wee bit of your thought process bubbles here. Okay. So instead of calling this u and v, I'm just going to call them a and b instead. Okay. So let a be equal to x and let b be equal to x plus 1 to the power of 4. Okay. And then instead of what we would normally say u dashed, we'll say a dashed is 1 and b dashed. Again, we apply the chain rule. So I've got 4 bracket x plus 1 to the power of 3 times it by 1, which doesn't change it. Okay. So then instead of dy by dx, we're trying to get what u dashed is. Okay. Or du by dx. And we can say, now we're used to u dot v dash, so we'll say a dot b dashed. Move that down slightly. A dot b dashed plus b dot a dashed. Okay, just the same as what we do with u's and v's. Now you can see that a is x and b dashed is 4 bracket x plus 1 times 3. When I multiply them together, I'm going to get 4x times x plus 1 to the 3. That x comes from here, that's the a. It's been multiplied by that, but I can obviously just jump straight to 4x times the bracket. Plus b, which is this bracket here, times a dashed, which is 1. So we can just write that as x plus 1 to the power of 4. I'm just jumping straight to this line to try and save some space here. Okay. What you could do is you'll notice that x plus 1 is common to both terms, and the highest common factor would be x plus 1 to the power of 3. So we could take out that common factor to simplify. So x plus 1 to the power of 3, which is being multiplied by 4x to get that first term, and then it's being multiplied by another x plus 1 bracket to get x plus 1 to the power of 4. Okay. What you can see here is that we can gather like terms. So I've got x plus 1 to the 3 being multiplied by 4x plus x plus 1, which then becomes x plus 1 to the 3, power of 3 I should say, multiplied by 5x plus 1. And that was du by dx, which is the derivative of u. So essentially that is our u dash that we're looking for. Okay. Okay, that's going to come in very important as we move on. If we go back up here and we look at V, we want to differentiate that as well. So keep this bit separate. That's me apply the product rule once. I'm then going to go back to what I had originally. I had U and I had V. I've now used the product rule a second time to find what U dashed is, and I have to get V dash now, which is 5 bracket 2x minus 1 to the power of 4 multiplied by the derivative of 2x minus 1, which is 2, giving me V dashed equals 10 bracket 2x minus 1 to the power of 4. Okay, so I'm going to double underline that. Okay, I'm just going to, let's see, double underline this one as well, so you can see what we're using. Okay, so the ones which are double underlined here are the ones which we're going to use for our product rule now. Okay, so going back to what I originally wanted to differentiate, which was this y term here, we can say this implies dy by dx is equal to u dot v dash plus v dot u dashed. So u is x bracket x plus 1 to the 4 times v dashed, which is this, 10 times 2x minus 1 to the 4. Now I've run out of room here, so this bit here I'm going to put just below it, plus v, which is 2x minus 1 to the power of 5, multiplied by u dashed, which if I just tilt that down slightly, you can see down here. So that's times x plus 1 cubed times 5x plus 1. Okay, so we have differentiated it, but we do need to tidy it up. It's very, very untidy at the moment. Okay, if I look at that top term, I could write the 10x at the beginning, and then I'm going to put x plus 1 to the 4, and then the 2x minus 1 to the 4. And then we've got plus, I'm going to put the 5x plus 1 at the start, that's only got a power of 1. And then I'm going to keep this in the same order, x plus 1 to the 3 and 2x minus 1 to the 5. Now if you focus on this bit here, what can you see as common factors? Okay, we always want to take out a common factor if we can, so that we can simplify it. There's nothing common with the 10x. There's nothing common with that 5x plus 1. But the x plus 1 we have to the power of 4 here in the first term, and we have the x plus 1 to the power of 3 here in the second term. So I can take out x plus 1 to the power of 3. Okay, and if I check this one as well, I've got 2x minus 1 to the 4 in the first term, and I've got 2x minus 1 to the 5 in the second term. So I can take out 2x minus 1 to the 4, and then say, what do I have to multiply that by? Right, so this first term here, I need to multiply it by a 10x, and I need to multiply it by another x plus 1. And then for my second term, I need to multiply by a 5x plus 1, and I also need another 2x minus 1 term. Okay. I'm just going to try and squeeze this in because I'm running out of space. So I've got my common factor here. What you can do now is, you can see when you multiply this out, you're going to get x terms and x squared terms and constants in here. Okay, and the likelihood is that we can multiply that out and then gather some terms together. So I'm going to leave x plus 1 cubed and my 2x minus 1 to the power of 4. I'm going to get 10x squared plus 10x, I'm multiplying those two. And then I've got a double bracket here, so I've got another 10x squared. I've got minus 5x, I've got plus 2x, and I've got minus 1. Okay, and you can see I've got some like terms which will gather together. So finally, I've got x plus 1 all cubed times 2x minus 1 to the 4, and 10x squared plus 10x squared gives me 20x squared. 10x minus 5x gives me plus 5x. Oh, sorry, and I've also got just rub that out. 10x take away 5x leaves me with 5x. I have to add another 2x on, which is going to give me 7x. And then I've got the minus 1 at the end. And that is your final answer. Okay. So that was a more complicated example. It started off with essentially a product of 3 terms. Imagine the u as the first 2 terms and the v is the last one. You have to apply the product rule initially here to get what u dashed is. Okay, you're applying a kind of mini product rule here to get u dashed. You also work out your v dash, so you've got u, v dashed, and u dashed, which then allows you to get your final answer for dy by dx using the product rule, and you got that u dashed from the bit in green. Okay, the hardest bit here was looking at what you've got, taking out any common factors and manipulating the algebra. That's probably the hardest bit. Okay.